Welcome back, students. Right now we're going to be covering the law of cosines. Last time we talked about the law of sines. Now the law of sines can be used to determine the measure of missing angles and sides when the measures of the two angles and a side, so using angle, angle, side, or angle, side, angle, or the measures of two sides and a non-included angle, side, side, angle are known. In other words, the law of sines, let's put that in simple language because that was a mouthful. Law of sines was great when we knew a specific angle and its opposite side. Then given any other piece of information, okay, if I had this angle and I wanted to figure out this opposite side, or if I had that side and I wanted to figure out that angle. So long as I have a pair of an angle with its opposite side, I could use any other piece of information to figure out the rest of that triangle. And so that's where law of sines was useful, when I had that angle mixed with an opposite side. Okay. However, the law of sines cannot be used to determine the measure of missing angles and sides of triangles when the measures of two sides and an included angle, side, angle, side, or the measures of three sides, side, 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 are known. Since the law of sines can only be used in certain situations, we need to develop another method to address other possible cases. This new method is going to be called the law of cosines. So let's go through the development of the law of cosines, see why this works, see the proof of it. So first we've got just a very general triangle, the triangle A, B, C. Okay, so that was our starting point. We started with that. Then from the vertex B, we drew an altitude, K. So that altitude, K, because it is an altitude, means that's a 90-degree angle right there. And it is drawn and it separates side B into two segments. Now, we don't know how big those different segments are. We knew the entire segment was the length of B. That's the name we're giving it since it's opposite of angle B. So we're just going to go ahead and arbitrarily say that this is length X. So the remaining length here is the length of B taking out X. So B minus X. All right, so that's how those got labeled. Now the altitude is going to separate ABC into two right triangles. So we've got this triangle here on the right, and we've got this triangle here on the left. Use the Pythagorean theorem to write two equations, one relating k, c, and b minus x, the other relating a, k, and x. So let's go ahead and we'll start over here on the left-hand side. Now they said to use Pythagorean theorem, so that's what we're going to do. We're going to do our a squared plus b squared is equal to c squared. Now a and b are just going to be the two sides that make up the right angle. So that would be b minus x squared, so there's a, plus b would be the k, so we're going to have k squared is equal to, luckily for us, c is c, c squared. All right, we're going to make one more, but this time with this triangle over here on the right. So we're going to have x squared plus the k squared is equal, and the hypotenuse was a squared. All right, so we've got those two. Now, we want to notice both of them have a k squared in them. So since they're both using that value, let's go ahead and solve for k so that way we can use that to relate these two separate equations to each other. So for this first one, I would minus the b minus x squared from both sides of this for this other equation, I'm just going to need to minus the x squared from each side. So that's going to give rise to the equation k squared is equal to c squared minus b minus x squared. And then for the other triangle, k squared is equal to a squared minus x squared. Great. Now, we've got those. Since both of these are equal to k, that means they can be equal to each other. If a is equal to b and b is equal to c, a has to be equal to c. So since they're both equal to k squared, they are also both equal to each other. So that's what I'm going to set up right now. So we got our b minus x squared should be equal to the a squared minus x squared. All right, so here's our new equation. Notice that the equation in question 3 involves x. However, x isn't even a side of ABC. As a result, we're going to attempt to rewrite this equation up here. And the reason for it is x and k, those were created out of our need to use a 90-degree triangle when using sine and cosine. But we want this to work with any triangle. So in order for it to work with any triangle, we're going to have to eliminate the need for x. We already eliminated the need for k, but we want to eliminate the need for that as well. So first, we're going to expand out that b minus x squared. So c squared minus, and that'll become a b squared minus 2bx plus x squared is equal to a squared minus x squared. Let's go ahead and distribute that subtraction. So c squared minus b squared minus, or sorry, now that's a plus 2bx minus x squared is equal to a squared minus x squared. Okay. Now we're going to solve all of this for c, so we're going to get c squared alone. So I just am going to move everything to the opposite side and then change its values. One thing to note, because we got a minus x squared here, when we add the x squared, we're also adding the x squared there, so that will eliminate. So we're going to have an a squared plus b squared minus 2bx. Dang it, we still have an x. So to eliminate that x from this equation, we're going to attempt to substitute in an equivalent expression for x. All right, so we're going to write an equation involving cosine c and x. So let's go ahead and look back up at our triangle. So here's c. All right, and right there is x. So cosine of c should always be the adjacent over the hypotenuse. So that'll be x over a. So cosine of c is equal to x over a. Great, I've got that. Here's why this is useful. We can solve for x to then know what we can substitute in for that x. So by multiplying both sides by a, we'd have a cosine of c is equal to x. Now that we've got this value for x, we can replace it with that x from 5, thus creating c squared is equal to a squared plus b squared minus 2b, rather than x, a cosine of c. And I'm going to do a quick rearrange. We've got BA, the obsessive compulsive part of my brain doesn't like that, so we'll put it just like that. Right there, we've got our equation for the law of cosines. Remember that the lowercase letters each represent a side, and then we've got this angle C. Now, it also helps us, I think, to remember the way these triangles are labeled. And we're going to go ahead and do that with colors, and hopefully that can help us to keep this all straight. So let's start out with A. We've got our B. And then C in there. Now, what's really important is to relate all of this back to our C. C is right there at the corner of A and B. So as you set up your triangles to be using the law of cosines, what you need to keep straight in your head is that C, the big C of the angle, is at the corner of sides A and B. And that little c is going to be that opposite one. All right, so let's go ahead and let's see how we might be able to use that. And I'm going to even try to take that down with me. If it'll let me. Nope, looks like it's completely disappeared. All right. Anyways, there's a quick review of the law of sines. If you don't remember that, please go back to the previous video. Here's our law of cosines. Now notice they do give us two ways. Here's what we just found. This one over here is the same equation. Notice all they did is they solved for the cosine of c. All right, so they minus a squared minus b squared and then divided by negative 2ab. And that's how we got this one. And notice the hint they're giving you. Use this one when you're looking to find a side. Use this one when you're looking to find an angle. All right, so let's go ahead and start. Now, right here, I've got opposites. This is a time for the law of sines. I've got an angle with its opposite side. It looks like I'm looking for the angle P. So if I come up here to my notes, I want to find an angle. So I'm going to do the sine of A over A, sine of B over B. That would translate into the sine of 86 over 25, which would then be equal to the sine of P over 9. So now we just need to solve for P. Multiply both sides by 9. So the 9 sine of 86 over 25 is equal to the sine of P. All right, to get rid of the sine, we need to do the inverse of sine. So that'll give us P is equal to the inverse of sine of 9 sine of 86 over 25. So that's going to be our exact answer. That looks like a bit of a monstrosity. So I would go ahead and open up Desmos. And we can just quickly type that in and find our answer. So I'm going to do sine of sine inverse. Oh, and to get that fraction, type the division first. 9 sine of 86 all over 25. And we were dealing with angles, so make sure to come up to the graph settings, change it to degrees. So that would be approximately 21. All right. Now this next one. Here's our challenge. We've got two sides. We don't have any opposites. This 29, I don't know angle R. This 15, I don't know angle P. This angle with 96, I don't know its opposite side. Can't use the law of sines here. Won't work. But I can use the law of cosines. Now, this angle that we know, remember, law of cosines only uses a single angle, C. So this is going to be my C. And it looks like we're trying to find side PR. So they tell us that to find sides, we're going to use this one on the right. So I'm just going to go ahead and write it first. C squared is equal to A squared plus B squared minus 2AB cosine of C. So let's start getting those things in there. Let's first start with C. So we're going to have the cosine of 96. Next, A and B were the sides that made up C. So I've got 29 there. So that's going to be a 29 squared. And let's put 29. I may need to be more careful and give myself more space. And then B is going to be that other side that makes it up. So plus a 15 squared. Doesn't look too pretty, but that'll still work. Minus, and then C squared, that's what we're trying to find out. That's what PR is. Well, look at that. We've got an entire expression that is just numbers. That's wonderful. That means a calculator can do the work. And we don't have to do any more. So I'll go over here, 29 squared plus 15 squared minus 29 times 15 times cosine of 96. Now we do have a problem with just that. Notice this was still C squared. So we're not 100% done yet. Because we know this is about 1111.47. So I need to take the square root of that. So SQRT. So C is approximately 33.34. And that is PR. All right, let's do another. Okay, once again, I have an angle with its opposite side. This time I am looking for a side, so if I go up to my handy little guide Law of sines, I'm trying to find a side. I'm going to put the sides on top, which makes sense. That's going to make things easier. So 44 over sine of 109 is equal to, and I'm looking for the side AB, so this side right here. I'm just going to go ahead and call it A. Or, well, actually, probably more accurately, since that side C, that's angle C, we'll call that side C. So I'll just put in a C there, and then that's sine of 37. To get that C alone, just multiply both sides by sine of 37. And now we're ready to go ahead and figure out what C is equal to. So we're going to do 44 sine 37 all over sine of 109, which is approximately 28. Okay, so that's the length of AB that they were trying to get us to find. All right, once again, I don't have opposites of angles and sides to combine, so this is a law of cosines situation. So I'm going to come back up. Well, actually, let's look at what they want us to find. They want us to find an angle. So notice the equation to find the angle. Cosine of C is equal to A squared plus B squared minus C squared over 2AB. All right, so one more look, sorry. Okay, cosine of C is equal to A squared plus B squared minus C squared all over 2AB. Now, our C is going to be the angle. All right, and then A and B must be the sides that make it up. Okay. Oh, so we've got a challenge here, actually. Notice we're trying to find the measure of this angle up here, but if I use law of cosines, which is really all I can even use right now, what it's going to help me to find, I feel silly for not seeing this earlier, is the length of that side. Okay? But that's not the angle we're looking for. But I don't really have a way of finding that angle yet because I don't have enough information. But if we find this side first, maybe we stand a chance. So I'm actually not looking for an angle. I'm going to rewrite this because what I am looking for instead is that side. And then we're going to use that side in the next step. So let's go ahead and rewrite that equation. So it should be C squared is equal to A squared plus B squared minus 2AB cosine of C. Now this is also kind of why I like to highlight. It helps me keep my brain clear as to where everything is and where it's going. And that helps keep me from making any mistakes. And that should tell me C. All right, I've got everything labeled. I know where all my numbers are going, and this will help me to find C. So let's go ahead and do that. So we're going to have c squared is equal to 23 squared plus 29 squared minus 2 times 23 times 29 times the cosine of 111. All right, now it's time for Desmos to earn its keep. And in fact, I'm going to go ahead and set all of this next equation equal to a variable. You'll see why in just a second. So I'm going to have a is equal to, or hey, we're talking about c. So let's say c is equal to 23 to the power of 2 plus 29 to the power of 2 minus 2 times 23 times 29 times the cosine of 111. Now, remember, all that told me is what c squared is. So c squared is equal to 1,848.1. So I need to take the square root of both sides. Now notice I went ahead and called that c, so I'm just going to do SQRT of c, so of this thing above. So that'll be 42.99. Now that number right there is that one missing side. But that is very important to us. Sorry, it just keeps on jumping about on me. 42.99. So now that I know the length of this side, I now have an opposite that I can now use to be able to use law of sines to find our missing angle. So I could do the sine of 111 over 42.99 is going to be equal to, there's that angle C that we're looking for, sine of C all over 23. All right, so we'll multiply both sides by the 23, so then sine of C is equal to a 23 sine of 111 all over 42.99. Now we're going to do the inverse sine of both sides. So sine inverse of 23 sine of 111 all over 42.99. Whew! Get my fraction by pressing divide. 23 sine of 111 all over 42.99. And we will get approximately that angle C is approximately equal to 29.97. There we go. All right. I know law of cosines is kind of a trickier one. Try and do what I do. Grab some highlighters. Make sure you're identifying this one is little c, this one's little a, this one's little b, and this is my big C. Make sure you've identified where everything is. Correctly remembering that angle C is made up by sides A and B. And if you do that and you do it properly, you'll be able to substitute just fine, and then the calculator can do the work. The hardest part of using the law of cosines is the substitution part and getting all of the numbers in the exact right spot. All right, good luck.